Okay, now we're asked to take the derivative of y equals x cubed and look at the trend of the values of the derivative. We've looked at the trend of the values of the slope. Now we're going to look at the trend of the values of the derivative. Well, derivative of y equals x cubed, that's very straightforward. Y prime equals 3x squared. What's the trend of the values of the derivative? Well, that's equivalent to asking basically, as x increases, what happens to the value of y prime? That is, to the value of 3x squared. So we could check the trend. We could let x take values like -2, -1, 0, 1, 2. And I asked people to check for some selected x values, and most people selected values kind of like this. And one person went from out to 4 and 6, okay? Maybe from -1 to 6 or something like that. So I've included those values here as well, because it gives us actually some kind of valuable information. Okay. Well, if x is -2, then what's the value of y prime? And right there's the evidence that I didn't put the prime on the y, but these are the values of y prime. Okay. We plug in -2. -2 squared is 4 times 3 is 12. Well, we know how to get these values. We plug the x values into 3x squared, and we write down what we get. Now, what's going on here? Okay, well, it looks like what we've got here is positive values decreasing to 0, and then after 0, positive values that start increasing again and continue to increase. Well, isn't that a lot like the trend of the slopes here, which decrease up to where x equals 0 and then start increasing after x equals 0? And yes, the words that we use here for slopes, or the statements we made for slopes, could be replaced by the same statement if we cross out the word slope and insert the word derivative. Up to x equals 0, the derivatives are positive and decreasing as x increases. So Lx is increasing, derivatives are positive but decreasing up to where x equals 0, and then past x equals 0, cross out the word slopes, past x equals 0, derivatives positive and increasing. Well, that's exactly what we see here. So the description we would make of the trend of the y prime values is the same as the descriptions we have for the slopes. Okay. Another way of writing that trend is the trend of the derivatives is to decrease at a decreasing rate. We're decreasing but not as fast, up to the x equals 0, and then start increasing but at an increasing rate. So I'm going to write something down here before I go on. I've decided I want to write this statement. The derivative y prime equals 3x squared is positive and decreasing up to x equals 0. And that perfectly mimics this statement if we replace the word slope with derivative. And then positive and increasing. And that, if we'd written it out a little more fully, would mimic this statement. So what we say about the derivatives is exactly the same thing we say about the slopes. And there's a good reason for that. As we've talked about extensively in the past couple of classes, the derivative at a point is equal to the slope of the graph at that point. So the derivative and the slope are telling us the same thing about this function. So replacing the word slope by derivative, or the word derivative by slope, we get the same statement, the same behavior observed independently, once just in terms of the graph and in terms of an approximate graph without doing any measurements, and another in terms of the derivative function. Now, the values that we get from the derivative function are exact. We didn't actually get any values here, we only got trends. If we graph y prime versus x, well, we're graphing then y prime equals 3x squared versus x. What's the graph of 3x squared look like? Well, it looks just like any other parabola until we put a scale on it. Okay? And then the scale gives us additional information, but would have the same shape. Well, that tells us that the derivative has this shape. The slope of the tangent line is just the value of the slope of the tangent line is just the value of the derivative at that point. So that the derivative function is going to be this yellow function here. Okay, and that is the slope function that you would get if you constructed a really good y equals x cubed graph and measured the slopes at a series of points and carefully plotted slope versus x and then connected it with a smooth curve. Okay, so re-emphasizing the fact that the derivative and the slope have this very close identity. And then there's another statement that I made over here. Another way of talking about the trend of the derivatives is the trend of the derivatives is to decrease. Well, I actually talked about that one a minute ago, didn't I? Again, it's getting a little late. Okay, decreasing at a decreasing rate, then increasing at an increasing rate.